In this video, we're going to download hourly data from the CoAgMet homepage, import that into Microsoft Excel, and then plot some of the humidity variables that we've been studying. So the first thing you have to do is I have the CoAgMet homepage up here, and on the back side I have my blank Microsoft Excel sheet that I want to import into. So I'm going to go down to Raw Data Access, and here's where I pick the data that I want to import. I want to get hourly data, not daily. But one thing that we need to do is import the headers so that we have the proper labels across the top of our spreadsheet. If you've done this once, you probably don't need to do it again, but if you've never done it before, you need to go down to Raw Data Documentation. And here we see CoAgMet Hourly Data Formats. It's 14 variables. I'm going to grab this whole chunk of text right here and hit Control-C to copy it. Go over to my blank spreadsheet. I'm actually going to paste it in the second row. And we can see that this is actually just one big column. But this is along the side. We want it along the top. So I'm going to select it again, copy it, Control-C. And now I'm going to paste special across the top. I'm actually going to paste it here in the B cell. And you can do paste special. And I'm going to select transpose. Okay, now that pasted it across the top. That looks good. I'm going to delete these now. And if you recall from previous video, one thing that CoAgMet doesn't mention is that it actually also puts the location in the very first column. So we're going to add that in there. You can't see all these, so one thing you can do is click on here and then go Format and then Auto Fit Column Width. And now we can see all the variable names across the top. So now we're ready to actually import the data. Now you may want to save this while you've got it here so you can use it over and over again. That's what I usually do. I'll go Save As. I'll put this over here in I might call it something like CoAgMet Daily Header. And save it. So now when I get ready to do this again or import more hourly data, I've already got the header information. I don't need to do this step again. So now I'm ready to import some data. So let's go back to the CoAgMet homepage. Back to CoAgMet Raw Data Access. Recall, you get to that from the main page. We want hourly data this time, not daily. I'm going to work in 2015. I'm going to start in July and end in August. I want to start, in this case, I think I'm going to start on July 30th and end on August 2nd. And for my location, we have lots of choices. I'm going to go with Greeley 4. Now, not all stations have complete records, so you have to be a little careful. Every once in a while you'll pick a station that has incomplete records, but I know that this Greeley 4 is usually pretty safe. So that all looks fine. Again, I have hourly data selected. Hit Submit. There's our ASCII results that are comma delineated. I click on it, just the page, and then hit Control-A to select all, then Control-C to copy it. Okay. Now it should be on my clipboard. I go back to Microsoft Excel, and I'm ready to paste it in right here. hit Control V. There's all the data, but we see that it is not delineated by commas. It's not in the correct rows. So at this point, once that's selected, you go to Data, Text to Columns, and you tell it it's delineated data, and you want to separate it by using tabs and commas. You can see that it looks correct down here. You hit Next. That all looks fine. I'm just going to hit Finish. And there we go. All our data is across the top now. And it looks like it all added up. The last column is under wind gust direction. So we have everything that we need. At this point, we have all the raw data. And usually, here's where I'm going to save it under a different file name. Let's say I'm going to call it Greeley 2015. I'm going to call it July, August, just to help me remember what I'm doing. And I'm going to remind myself that it's hourly data. I'm going to save it. So at this point, I have the data, and I'm ready to plot it or work with it or do whatever I want. A lot of the time, I'll go ahead and rename this sheet down here. Note you can rename this by right-clicking on it. I'm going to call it Data, just to keep it separate from anything else that I'm doing. So if we wanted to, we could make plots now to see what the results look like. We did get data from July 30th through the end, right to the midnight on the 2nd. So let's say I click on the date and plot something like temperature. I can say insert. For charts, I'm going to insert scatter. You can pick different choices here. A good one is the scatter with smooth lines or scatter with straight lines and markers. So I clicked on that, and there I have it. I could move the chart over to a new sheet called temperature. We can see it there. It's pretty nice looking data, getting up close to 95 degrees Fahrenheit there. The format, I can modify that. You know, a lot of the time I use the quick layout. But let's go back to the data and add something, calculate some kind of new variable. So right here we have the mean temperature every hour, the relative humidity every hour, and the vapor pressure. Okay. Let's say that we wanted to calculate the vapor pressure deficit, which is used in a lot of our ET equations and also used in to calculate the drying power of the air. So I'm going to insert a new column here, and I'm going to call it VPD. It's also in kilopascals. But we remember that VPD is actually the difference between the saturation vapor pressure and the actual vapor pressure. I've got the actual vapor pressure right here, but I don't have saturation vapor pressure, so I'm going to need to calculate that first. So I'm going to insert another column, call it saturation vapor pressure in kilopascals. Okay, so now we need to calculate saturation vapor pressure, which is a function of temperature. If we look at our notes from over on Canvas, remember we had a humidity example calculations PDF. And if we look here, we can see that one of the first things we learned how to do was calculate the saturation vapor pressure using Teton's formula, and we can use the Buck or Murray equations. So let's put that in here. We'll try to set it off here to the side so we can see it. we want to put this formula here in this, right here in this cell. So I'm going to hit the equal sign, and I'm going to put in my Murray's equation, which is 0.611 times exp, the exponential, 17.269 times temperature in Celsius, so I can just click on this cell, C2, divided by, need some parentheses down here, again the temperature, plus 237.29. And I need another parentheses. So if I hit return, gives me my saturation vapor pressure right here. Okay, that's probably more decimal points than we need, so we can go up here and reduce those. All right, so it's consistent with this one. Then I'm going to copy this formula all the way down. To do that, I double click on this little square in the bottom right hand corner of the cell, and there it is. So there's the saturation vapor pressure. It should be larger than the actual vapor pressure, and we see that it is in most cases. Of course, it'll get, if the humidity gets very high, they'll be very close. So now I'm finally ready to calculate VPD equals the saturation vapor pressure minus the actual vapor pressure. Okay, there it is. I can do the same thing. Highlight the cell and double click on the bottom right hand corner. And there it is. We could take a quick look at that if we wanted to. In fact, let's plot that against time. So we select the date time cell and the VPD, and we go up to insert. Again, I want a scatter plot or something with lines on it here. Let's do this one. Let's again right click on it and move chart. Move it to a chart called VPD. And now we can see it there. I'm going to go ahead and use the quick layout tool. And we can see that the vapor pressure deficit has a diurnal pattern, maxing out around noon each day and then getting very small at night. Remember, this is the drying power of the air. So we would expect evaporation or transpiration or ET to sort of follow this same pattern. We can see that the VPD got really high on this particular day, August 1st. So that gives you a sense for how VPD is calculated and can be done. Let's go back to our data and even add another variable. Let's calculate the dew point temperature. So I'm going to insert another column, call it Tdew, and that's in degrees C. A lot of the time you have to add a space after the C or it tries to put the copyright symbol in there. Now let's go back to our notes and see how we calculate dew point. Okay, we can calculate dew point using this formula where we put the actual vapor pressure back into an inverse of the Tdew equation, or I showed you another little version down here that can be calculated directly from the relative humidity and air temperature. So we could use either one of those. We already have vapor pressure, so this would sort of be the logical one to use at this point. We'll set it right there so we can see it, and then let's put the formula in here now. See if I can squeeze it all in here. So Tdew is going to be equal to we use the Buck equations, 240.97 times the natural log of the actual vapor pressure over here divided by 0.611. Okay, and that entire expression is divided by, and we're going to need a parentheses here, 17.502 minus the natural log, that same term again, the vapor pressure divided by 0.611. And we hit return, and there's our dew point temperature. So just a quick check, there's the dew point temperature. Here's the actual temperature. So we would expect that to be lower here in the summer. I'm going to highlight the cell, double click, and fill it in here. So now let's make a plot of air temperature and dew point temperature. That might be interesting. Date and time. Hold down the control key to select another cell. Hold down the control key. So I've selected these three cells. My date time variable is going to be on the x-axis, and I should get a plot of both air temperature and dew point temperature. Go to Insert, and I want to insert a chart. Let's do this one again. Looks good. I'm going to right click on it, move the chart. I'm going to call it Tair underscore Tdew. Alright, and I'm going to hit my quick layout. And now I can see I'm starting to develop kind of an interesting chart here. Here's the dew point temperature. You see it fluctuates quite a bit during the day. We also noticed that after this first night, the air temperature got really close to the dew point temperature here. Good chance we had dew formation during that period. Not quite so much the night before, okay, or the first night. So this helps you see, of course, this must have been a period of very high humidity, okay, during that period. And we could even add the relative humidity to this if we wanted to see if that was a period of very high humidity. But we can go ahead and get our chart sort of fixed up while we're doing that. Let's go ahead and do that. So this variable is temperature. In degrees C, either air temperature or dew point temperature. Date and time. Probably just date time would be fine. You can change the chart title. And the only thing, it's looking pretty good, except I don't like this formatting down here. You can click on that and on that axis and pull up your format axis options, and it says here that it's linked to the source. You can change that if you want to and put in something sort of custom. You could put in just times if you wanted to, or something like this. Okay, that makes it a little bit easier to read. You could add some tick labels. I also like to format my plot area. I like a line along this side. And I usually like to make it a little thicker. So there you go. So now we've got a plot that's looking very readable. Could move this over if we wanted to. Change the size of the fonts a little bit. Back to home. Just demonstrating here how you can make a little bit. Most of you probably already know this stuff.